AI Speculative Execution: How Senior Engineers Build Predictive, Low-Latency AI Systems in Production. Welcome to Agentic AI World. I'm your host, and this is episode 49 of your daily AI engineering interview prep series. Today's topic: AI Speculative Execution: How Senior Engineers Build Predictive, Low-Latency AI Systems in Production. Let's start with the core problem. In production AI systems, latency is the enemy. Users expect instant responses, but LLMs are slow. A typical GPT-4 class model takes 2 to 5 seconds to generate a complete response. What do you do when your SLA is under 1 second? You speculate. Speculative execution borrows a concept from CPU architecture. Modern processors don't wait to know what instruction comes next. They predict it and execute ahead of time. If they're right, you save cycles. If they're wrong, you discard the work and try again. AI systems can do the same thing. The most common form is speculative decoding. Here's how it works. You have two models, a small, fast draft model and a large, accurate target model. The draft model generates 5 to 10 tokens in parallel, very quickly. Then the target model verifies all those tokens in a single forward pass. If the draft tokens match what the target would have generated, you keep them all. If they diverge at token K, you accept tokens 1 through K-1 and regenerate from K. The net result? You get target model quality at near draft model speed. Speedups of 2 to 4 times are common in practice. Interview question: walk me through speculative decoding end to end. How do you handle rejection? What happens to throughput versus latency? The answer interviewers want to hear. Draft model runs auto-regressively to generate a candidate sequence. Target model scores the entire sequence in one batched forward pass. You accept greedily up to the first divergent token using a modified rejection sampling algorithm. If you accept all K draft tokens, you get a bonus token from the target model's distribution. Net throughput improves because target model forward passes are expensive. Batching K tokens together amortizes that cost. Now let's talk about a subtler form: speculative prefetching. In agentic systems, you often know the user's next likely action before they take it. A customer support agent that just resolved a billing issue. The next likely request is a receipt or a refund status. You can preload context, pre-embed likely documents, and warm up the model's KV cache before the user even types. When the request arrives, you're already halfway done. This is sometimes called intent prediction or proactive context loading. It requires a lightweight classifier or a simple heuristic that maps current session state to likely next states. Build a Markov chain over your session logs. Train a small BERT class model on user journeys. Even a rule-based system based on navigation patterns works in practice. Interview question: how would you implement speculative context loading for a multi-turn AI assistant? Strong answer: log user session sequences. Build an Ngram or ML-based next intent predictor.